We're going to look at what's called synthetic substitution and the remainder theorem. If you divide a polynomial, p of x, where the degree is greater than or equal to 1, by x minus a, then the remainder is p of a. In simpler terms, think of synthetic division. When you divide by, let's say, x minus a, that remainder on the end of synthetic division is the same as what you would get if you substitute a in for x into that polynomial. So given that p of x equals x to the fifth minus 2x to the third minus x squared plus 2, what is p of 3? In other words, what do you get when you substitute 3 in for x? Now we're used to substituting 3 in for x, evaluating the exponents, working that out. But this synthetic substitution is a much simpler way, much faster, more efficient. By the remainder theorem, p of 3, in other words, substituting 3 in for x, is the remainder when you divide p of x by x minus 3. So again, think of synthetic division. How do we set that up? We'll look for any skipped or missing terms. You're missing an x to the fourth term, so you have to fill in with a 0x to the fourth, and then list the coefficients. So we're going to list 1, 0, negative 2, negative 1, 0, and 2. List the coefficients. Now you're dividing by x minus 3. So you're going to put a positive 3 in the box. What we're doing here is we're substituting 3 in for x. So again, we're putting a positive 3 in the box. And now you just proceed with the process of synthetic division, which in this case is synthetic substitution. That number we get on the end, that remainder, is the value we're looking for, the value that is when you substitute 3 in for x. So proceed with synthetic division, now known as synthetic substitution. In this case, bring down that 1. So bring down that first coefficient, bring the 1 down, and then multiply 3 by 1. So if you multiply 3 by 1, that is going to be 3. And then you're going to add 0 and 3. So if you add 0 and 3, that is 3. Then go back to the box and multiply 3 by 3. That is 9. And then add negative 2 and 9. That is 7. Back to the box, multiply 3 by 7. That is 21. And then add negative 1 and 21. That is 20. So we're just proceeding with what used to be known as synthetic division, but we're using it now as synthetic substitution. We're looking for this number on the end, this remainder. That's what we would get if we substitute 3 in for x. So proceed with this. Back to the box. 3 times 20, that is 60. If you add 0 and 60, that is 60. Back to the box. Multiply 3 by 60. That is 180. And if you add 2 and 180, that is 182. That's the number we're looking for. So that's what you get when you substitute 3 in for x into this polynomial. Now just to check that with the old-fashioned way of substituting in, I'm going to manually go through and substitute 3 in for x. So when you do that, you have 3 to the fifth minus 2 times 3 to the third minus 3 squared plus 2. Evaluate 3 to the fifth, it's 243. 3 to the third is 27, and 3 squared is 9. Multiply 2 times 27, that is 54. So you have 243 minus 54 minus 9 plus 2. Cross your fingers and hope that we get 182. And we do. If you add and subtract there, that is 182. So you can see that when you substitute 3 in for x, you get 182. But it's a much more efficient way to use synthetic substitution than the old method of substituting in. Given that p of x equals x to the fifth minus 3x to the fourth minus 28x to the third plus 5x plus 20, what is p of negative 4? So what do you get when you substitute negative 4 in for x? We're going to use synthetic substitution. First step is to look for any skipped or missing terms. So just count down the exponents. You have exponents of 5, 4, 3. We're missing an exponent of 2, so you'll have to fill in there with a 0x squared. Then you have an exponent of 1 and the constant term. So fill in with a 0x squared. And then just like synthetic division, we're going to list the coefficients. You have coefficients of 1, negative 3, negative 28, 0, 5, and 20. So list those coefficients. And you're substituting negative 4 in for x, so negative 4 goes in the box. It's just like if you were dividing this polynomial by x plus 4, this remainder, this number on the end, is the same as what you get when you substitute negative 4 in for x. So just like synthetic division, we're going to bring down that first coefficient, bring down the 1, and then go back to the box and multiply negative 4 by 1, that is negative 4. And then add negative 3 and negative 4, that is negative 7. And then you just multiply and add from there on out. Go back to the box and multiply negative 4 by negative 7, that is positive 28. Then add negative 28 and 28, that is 0. Back to the box, multiply negative 4 by 0, that is 0. And then add 0 and 0, that is 0 again. Back to the box, multiply negative 4 by 0, get another 0. And then add 5 and 0, get 5. And finally, go back to the box, multiply negative 4 by 5, that is negative 20. And then add 20 and negative 20, that's the number we're after right there. That's the remainder if you would divide this polynomial by x plus 4. But that's also what you get when you substitute negative 4 in for x. So if you're asked what do you get when you substitute negative 4 in for x, you get 0. Just to check that, we'll do the old-fashioned substitution where you manually substitute negative 4 in for each one of these x's. This is much more time-consuming. So if you do that, you have negative 4 to the 5th, minus 3 times negative 4 to the 4th, minus 28 times negative 4 to the 3rd, plus 5 times negative 4, plus 20. Evaluate all those exponents, get 1024 minus 3 times negative 4 to the 4th is 256. Then negative 28 times negative 4 to the 3rd, it's negative 64. Minus 20 and plus 20. Negative 3 times 256 is negative 768. You can see the time that's put into this. Negative 28 times negative 64 is 1792. And then just add and subtract from there. We still get 0. You can see this synthetic substitution is much more efficient than manually substituting in. 0 is the answer. Use synthetic division and the remainder theorem to find P of A. So we have P of x equals x to the 3rd plus 4x squared plus 4x. We need to find where A is negative 2. Now don't get confused. It says find P of A. What we're doing is substituting negative 2 in for x because this is P of x. So you could go in and manually replace each x with negative 2, or you could use synthetic substitution. If you're using synthetic substitution, first thing you do is look for any skipped or missing terms. Count down the exponents. We have exponents of 3, 2, and then 1. So we are not skipping or missing any terms. So list the coefficients as you see them. We have coefficients of 1, 4, and 4. Then you're substituting negative 2 in for x. So negative 2 goes in the box. It's the same as what you would get if you divide this by x plus 2. This remainder on the end is what we're looking for. So proceed with synthetic substitution. Bring down that 1 and then multiply negative 2 by 1. That is negative 2. And then add 4, negative 2. That is 2. Go back to the box and multiply negative 2 by 2. That is negative 4. And then add 4, negative 4. You get 0. That's what we're looking for. That's what you get when you substitute negative 2 in for x. That remainder is what you would get if you would divide this polynomial by x plus 2. So 0 is the answer to that. Use synthetic division and the remainder theorem to find P of A. We have P of x equals 2x to the 4th plus 6x to the 3rd plus 5x squared minus 45. I want to find out what that is when A is negative 3. Now don't get confused. This says find P of A. Here we have P of x. So we're really just substituting negative 3 in for x. But we're not going to use manual substitution. We're going to use synthetic substitution. First step is to look for any skipped or missing terms. Just count down the exponents. We have exponents of 4, 3, 2, and then you're missing an exponent of 1. So you'll have to fill in with a 0x to the first. And then minus 45. So fill in with a 0x. Then just like synthetic division, list the coefficients. We have coefficients of 2, 6, 5, 0, and negative 45. So list those coefficients, and then you're substituting negative 3 in for x. So negative 3 goes in the box. Just like dividing this polynomial by x plus 3, this remainder on the end, that's what we get when we substitute negative 3 in for x. So just like synthetic division, bring down that first coefficient, then you just multiply and add. So bring down that 2, go back to the box and multiply negative 3 by 2, that is going to be negative 6, and then add 6 and negative 6, that is 0. Back to the box, multiply negative 3 by 0, that is 0, and then you add 5 and 0, that is 5. Back to the box, multiply negative 3 by 5, that is negative 15, and then add 0 and negative 15, that is negative 15. Back to the box, multiply negative 3 by negative 15, that's positive 45, and if you add there, you get 0. So 0 is what we get when we substitute negative 3 in for x. 0 would also be the remainder if we would divide this polynomial by x plus 3. So 0 is the answer on that one. Use synthetic division and the remainder theorem to find P of A. In other words, use synthetic substitution. So we have P of x equals 2x to the 3rd minus x squared plus 10x plus 5. I want to find out what that is when A is 1/2. So we're finding P of A. This is p of x. We're just substituting 1/2 in for x. And we're going to use synthetic substitution. Now, just because that's a fraction doesn't change anything. You still proceed with synthetic substitution in the same manner. So look for any skipped or missing terms. Count down the exponents. We have exponents of 3, 2, 1, and then the constant term. So there are no skipped or missing terms. So list the coefficients. We have coefficients of 2, -1, 10, and 5. List those coefficients. You're substituting 1/2 in for x, so 1/2 goes in the box. And then bring down that first coefficient, so we're going to bring down that 2. Then you just multiply and add. Go back to the box, multiply 1/2 by 2, that is 1. Then you're going to add -1 and 1, that is 0. Back to the box, multiply 1/2 by 0, that is 0. Then add 10 and 0, that is 10. And go back to the box and multiply 1/2 by 10, that is 5. And when you add 5 and 5, that is going to be 10. So that 10, that is what you get when you substitute 1/2 in for x. What is p of -2 given that p of x equals x to the 4th minus 3x squared plus 5x plus 10? We're going to use synthetic substitution. First step is to look for any skipped or missing terms. Just count down the exponents. We have exponents of 4, then an exponent of 2. So you're missing an exponent of 3. We're going to have to fill in with a 0x to the 3rd. Then you have exponent of 2, exponent of 1, and then the constant term. So missing that exponent of 3, fill in with a 0x to the 3rd. Then list the coefficients. We have coefficients of 1, 0, -3, 5, and 10. So list those coefficients. Then you're substituting -2 in for x, so -2 goes in the box. Bring down that first coefficient, so we're going to bring down that 1, and then you just multiply and add. Go back to the box and multiply -2 by 1, that is -2. And then add 0 and -2, that is -2. Back to the box, multiply -2 by -2, that is +4. Then add -3 and 4, and that is +1. Go back to the box and multiply -2 by 1, that is -2. Then add 5 and -2, that is +3. And back to the box, multiply -2 by 3, that is -6. Then add 10 and -6, that is +4. So that is what you get when you substitute -2 in for x. Need to find the error. A student used synthetic division to divide x to the 3rd minus x squared minus 2x by x plus 1. What is the error shown? So this is their work for using synthetic division to divide those two. Well, the error is that when you divide by x plus 1, remember you switch the sign on that 1, and that's the number that goes in the box. So there should be a -1 put in that box if you're dividing by x plus 1.